picture this scenario, right? Because we have all either been there or we basically live in dread of it.
Oh, absolutely.
Yeah, so it is the dead heat of July. You walk into your house and it just feels like an oven. Your air conditioner's been running nonstop for days. And then, you see it.
The dreaded puddle.
Exactly. A dark, ominous puddle of water just creeping out from beneath your indoor AC unit. Or maybe even worse, you go to check the thermostat and the screen is completely blank. Just dead.
Yeah, it's a highly relatable, panic-inducing moment.
It really is. Your brain immediately jumps to the worst case scenario, right? You start calculating the cost of like a blown compressor or total system replacement.
Which is the absolute definition of a homeowner's nightmare.
Yeah.
Because, I mean, in that moment, you aren't just losing comfort, you're looking at impending structural damage.
Right, to your ceilings, your walls.
Your flooring, all of it.
And that panic is exactly why we are doing this deep dive today. We are pulling insights from a fantastic source. It's an expert interview transcript from a show called Cool Talk.
Yeah, they feature Dave Hartzell.
Right. He's a seasoned HVAC company owner out of Kingfisher, Oklahoma. And he has spent decades diagnosing these exact failures. So the mission of today's deep dive is to decode exactly what your air conditioner is trying to tell you when it leaks.
Right, we need to figure out why those quick DIY fixes you find online usually lead to, well, much bigger disasters.
Yeah, and explore how you can actually protect your home. Because staring at a puddle in your hallway is terrifying, but, understanding the physics behind it changes the entire game. So, okay, let's unpack this.
Well, to understand the physics, we have to look past the puddle itself, right? We need to completely reframe how you think about your air conditioning system.
How so?
Because most people view an AC unit strictly as a machine that manufactures cold air. But cooling is really only half the equation.
Right.
The other half is dehumidification. Your air conditioner operates like a massive mechanical sponge. It literally wrings the moisture right out of the air inside your home.
So an average residential unit isn't just cooling. It's extracting an enormous volume of liquid.
Oh, massive amounts. Depending on the humidity, a standard central AC system can pull up to 20 gallons of water a day out of your indoor air.
Wait, 20 gallons?
Every single day.
Yeah.
It is a massive amount of fluid constantly moving through a system that's just hidden in your walls or your attic.
20 gallons of water equates to about a bathtub's worth of liquid being generated every few days.
Exactly.
Yeah.
And the system is designed to handle this through a very specific cycle. Warm, humid air from your house is pulled through the return vents, and it passes over the indoor evaporator coil.
And that coil is exceptionally cold, right?
Freezing cold. So when the warm air hits it, the moisture condenses, it drips down into a primary drain pan, and then it's channeled out of your house through a PVC drain line.
It's kind of like a glass of ice water sweating on a hot patio table.
Yeah, that's a perfect analogy.
Except this glass is hidden in your walls and is pumping out gallons of water.
Right. And seeing water continuously dripping from that pipe outside your house is actually the ultimate sign of a healthy system.
So water moving is fine. Moving water means the system is functioning. But sitting water is the red flag.
Precisely. If that primary pan cannot drain, the water level rises until it spills over into an emergency secondary pan.
And if water is sitting stagnant in that emergency pan, you are basically on borrowed time before it breaches the edges and, destroys your drywall.
They're ticking down to a disaster.
Which brings up a really important mechanical question. If the water is supposed to just obey gravity and flow outside through a standard 3/4-inch PVC pipe, why does it suddenly stop?
Well, the blockage comes from the microscopic debris that is constantly circulating through your living space.
Okay, but the environment inside that drain line is what?
Incredibly harsh.
Oh.
It is pitch black, it's constantly wet, and usually it's hovering around 80 degrees if it's in an attic or utility closet.
Right, but here's where it gets really interesting, right? Because if it's just, a bit of household dust and some skin cells, how does it completely block a solid pipe?
What's fascinating here is the compounding effect. It starts small, but you have to remember that dark, damp, warm environment. It is a biological breeding ground.
Oh, okay.
Yeah, bacteria and algae thrive in that PVC pipe. They create what's called an extracellular polymeric substance.
Which means what, in plain English?
It's essentially a sticky, slimy matrix on the inner walls of the pipe.
Oh, wow. So it's not just a physical buildup of dirt. It's like a living layer that acts like glue.
Exactly. That sticky biofilm catches the first microscopic skin cell. Then it catches a fiber of lint. And the algae actually feeds on this organic matter, so it grows thicker.
Okay, so during a mild month, like say May, the AC might only run in short bursts, right?
Right, and the water just gently flows over the small buildup. It's no big deal.
But then July hits.
And the AC runs for 12 hours a day. The sheer volume of water, debris, and heat increases exponentially. In just one hot week, that biofilm catches more and more debris until it creates a solid, impenetrable plug.
What the industry calls sludge.
You got it. It goes from a minor restriction to a catastrophic blockage just because the heat dialed up and the system started running longer cycles.
And this creates a major illusion for homeowners, right? What Dave Hartzell calls the false fix.
Yes, the false fix. Because you see, the pan is full of water. You go outside with a wet shop vac. You suck the sludge out of the drain line.
And the water flows again. So you assume you solved the problem, you saved a service fee, you feel like a hero.
Right. But why is it a false fix? Because clearing the line once doesn't fix a design flaw or the environmental conditions that allowed the sludge to form in the first place.
Like what? What kind of flaws?
Well, for example, if that long run of PVC pipe in your attic has a belly in it.
A belly, like it sags.
Yeah, meaning it wasn't supported properly and sags in the middle. It creates a permanent trap where water sits stagnant even when the system is off. So the sludge will just grow right back in that belly.
That makes sense.
Or if your older metal drain pan is deteriorating and shedding flakes of rust into the water, or even if the outside pipe outlet is just buried in landscaping mud, the clog is going to return in a matter of weeks.
Right, because you're treating the symptom, not the structural flaw.
Exactly.
And when that structural flaw inevitably causes the pipe to choke again, the water backs up into the emergency pan and starts rising.
But before it overflows onto your ceiling, a hidden mechanism usually kicks in.
The float switch.
The float switch. It really is the unsung hero of modern HVAC systems. It is a small safety device installed either directly in the lip of the emergency pan or clipped onto the drain line itself.
Okay, mechanically though, how does a tiny plastic bobber sitting in a pan of water manage to completely kill a massive 240-volt outdoor compressor and a blower motor?
Well, it doesn't handle the high voltage directly. The float switch is actually wired into the low voltage control circuit.
Ah, the 24-volt wire that runs from your indoor unit to your thermostat.
Right, so inside that little plastic bobber is a magnetic reed switch. As the water level rises in the pan, it lifts the float.
And then?
When the float reaches a certain height, the magnet moves and physically breaks the electrical connection on that thermostat wire.
So the thermostat instantly loses power.
Yep, which immediately shuts down the entire cooling operation.
I mean, it's exactly like a smoke detector chirping at 3 a.m.
It's highly annoying.
Yeah. Your first instinct is to just rip the battery out to stop the annoyance so you can go back to sleep. But doing that leaves the house totally unprotected.
And in the dead of summer, when your house is sweltering and the thermostat goes blank, it feels like a punishment to the homeowner.
Oh, for sure. So people get frustrated and want to bypass the switch just to get the cold air back on.
It's a severe psychological trap. People get so desperate that they go up to the unit, find the float switch, and literally pull it out of the water. Or they figure out how to wire around it to force the system to run.
Which is crazy because bypassing that switch is basically inviting a flood into your home.
Exactly. The switch didn't fail. It operated perfectly to prevent a disaster. The enemy is the water. Bypassing the switch turns a simple service call into catastrophic water damage.
Okay, but what happens if you find a flooded pan, your thermostat is blank, and you go check your drain line and it's completely clear? No sludge, no belly, no blockage anywhere.
This is one of the most counterintuitive failures you can encounter. Because you have a flooded pan, but the plumbing is flawless.
Right, so where's the water coming from?
It's actually coming from a much more dramatic failure. The indoor coil has frozen into a solid block of ice.
So what does this all mean for the homeowner staring at a puddle? How does heat cause a block of ice?
If we connect this to the bigger picture, it all comes down to the relationship between pressure, temperature, and airflow. The AC system doesn't actually create cold air. It removes heat from your home's air.
Okay.
The refrigerant inside the evaporator coil enters as a cold liquid. It relies on a constant, heavy flow of warm air from your house blowing over those metal fins to provide the heat necessary to boil that liquid refrigerant into a gas.
So the warm air from the house is basically the fuel that keeps the chemical reaction balanced.
Correct. If you restrict that airflow, say, by letting your air filter get completely caked in dust and pet hair, the warm air never reaches the coil.
Oh, I see.
Without that heat load, the refrigerant doesn't boil off properly. The temperature of the coil drops below freezing, and the moisture that normally condenses and drips away, it now instantly freezes directly onto the metal fins.
Wow. And what if the airflow is fine, but the system has like a tiny refrigerant leak? Because I've always been confused by this. Why does having L-cells cooling fluid make the coil colder? That feels completely backward.
It really does. But it's all about pressure. In a closed refrigeration system, pressure and temperature are directly linked. If you lose refrigerant, the pressure inside the evaporator coil drops significantly.
And according to the laws of thermodynamics, when the pressure of a fluid drops, its boiling point drops with it.
Exactly. The remaining refrigerant in the coil becomes drastically colder than it's supposed to be, again dropping the surface temperature of the metal well below freezing.
So whether it's a suffocated air filter or a slow leak, the coil drops below 32 degrees, and all that humidity the system's pulling out of the air turns to ice.
It builds and builds until the entire indoor unit is encased in a solid glacier.
But eventually the system shuts off, right?
Right, maybe the house finally reached the target temperature, or the ice blocked the airflow so severely that the blower motor overheated and tripped a thermal limit.
And once it turns off,
You have a 50-pound block of ice sitting in a hot 80-degree closet.
oh man, it melts rapidly.
Incredibly rapidly. It dumps vastly more water into the drain pan all at once than that 3/4-inch drain pipe was ever engineered to handle.
It's like trying to drain a full bathtub by pulling the plug, but the drain is the size of a drinking straw.
Exactly, the pan simply overflows.
And the homeowner walks up, sees a massive puddle, and immediately concludes they have a clogged drain line. They might even try to vacuum it out, see water flowing, and think they fixed it.
But because the symptom is a flood, they completely miss the actual disease.
This symptom is not the diagnosis.
Yes. If a technician or a homeowner clears out the water and assumes it was a simple clog without investigating the state of the coil, they are leaving a ticking time bomb.
Because the airflow restriction or the low refrigerant was never addressed.
Right. The moment you turn the system back on, it will immediately begin freezing into a solid block again, and you'll have another flood tomorrow.
Okay, so if the symptom can mean either a biological clog or a thermodynamic freeze, how do you safely figure out which one you're dealing with before calling a professional? Let's walk through the actionable, smart troubleshooting steps.
The very first step is damage control. If you see water rising near any electrical components, or if the emergency pan is actively brimming, go to the thermostat and turn the system completely off. Do not let it keep running and fighting the safety switches.
Makes sense. Once it's off, I assume the next step is investigating the airflow.
Yes, check the air filter immediately. A totally packed, filthy filter is the #1 cause of the airflow restriction that triggers the freezing process. If it looks like a sweater, replace it.
It sounds so basic, but it causes catastrophic failures.
Hmm.
Okay, what's the next safe step?
Go outside and inspect the termination point of the drain pipe. Landscapers might have accidentally buried the outlet in mulch or mud. A lawnmower might have hit it and kinked the pipe. The water needs a clear exit path.
And if your system is located in a basement or an interior closet where gravity draining isn't possible, you likely have a condensate pump, right?
Yes, and that changes the troubleshooting slightly.
How so?
A condensate pump is a small mechanical box sitting next to your indoor unit. The water drains into a reservoir in this box. Inside the reservoir is a small float. When the water lifts that float, it triggers a microswitch that activates a centrifugal pump.
Physically pushing the water up and out of the house through a flexible vinyl tube.
Exactly. You need to listen to see if that motor is actually humming and look to see if the plastic reservoir is overflowing. If the pump motor has burned out, the water has nowhere to go.
So checking the filter, clearing the outside pipe, and verifying the pump is running all very manageable. But we need to discuss the DIY disasters.
Oh boy. Yikes.
Because people get desperate when service companies are booked out for a week. They find a quick hack online, and they end up causing thousands of dollars in secondary damage.
The risks of aggressive DIY on an HVAC drain system are incredibly high because you are dealing with hidden plumbing.
Right. A perfect example from the source is using compressed air to blow out a clog. People hook up an air compressor to that tiny plastic pipe and blast it with 100 psi.
Which is a terrible idea. What they don't realize is that condensate drain lines aren't always glued at every single joint, especially inside the air handler cabinet, where technicians need access for maintenance.
So hitting it with high pressure easily blows a weak pipe fitting entirely loose deep inside a closed wall cavity.
And you won't even know you did it until days later when the AC is running. The pipe is disconnected inside the wall, and water starts pouring directly through your drywall into your living room.
You turn a simple drain clog into a major home renovation. Yikes.
Yep.
The other dangerous hack is pouring harsh chemicals down the line. People think heavy-duty liquid drain cleaner will just melt the sludge away.
Condensate systems are not built to withstand caustic plumbing chemicals. If you have a condensate pump, those chemicals flow into the reservoir and can literally melt the ABS plastic components or destroy the rubber seals inside the pump motor.
That's horrible.
Furthermore, the evaporator coil is constantly pulling air over that drain pan and blowing it into your living space. Pouring harsh chemicals into the pan can create toxic fumes that are immediately distributed through the ductwork into every room of your house.
So you're trying to clear a clog, and you end up destroying a mechanical pump and circulating poison into your breathing air.
Exactly. This highlights the real value of a proper diagnostic visit from a professional. When a technician arrives in the middle of a July heat wave, their job isn't just to make the water vanish for an afternoon.
Right, because July heat is unforgiving. A weak drain system that barely survived May will fail entirely when running all day in July.
A proper diagnostic involves a comprehensive structural inspection. A technician needs to verify the physical slope of the pipe with a level to ensure gravity is actually pulling the water.
And they need to inspect the P-trap, right? The curved section of pipe that prevents sewer gases or unconditioned air from being sucked back into the unit.
Yes, to ensure it's holding water correctly and isn't blocked.
They also need to rigorously test the electrical circuit of that safety float switch, I'd imagine.
Absolutely. They must manually trip the switch to guarantee it will successfully kill the power in an emergency. And above all, they have to determine the true origin of the excess water.
So if they find evidence of a frozen coil,
They must hook up their gauges, check the refrigerant pressures, and measure the airflow to fix the root cause. It is about preventing a future failure, not just applying a temporary Band-Aid to a symptom.
it is about finding the disease, not just treating the fever. Man, we have covered a massive amount of technical ground today. Let's quickly recap the journey.
Let's do it.
First, your AC is effectively a giant dehumidifier, safely pulling up to 20 gallons of moisture out of your house every single day. Second, the enemy of that system is biofilm and sludge, a living matrix of algae, skin cells, and dust that compounds in the heat and chokes the plumbing.
Third, the float switch that abruptly turns off your cooling is a critical safety mechanism designed to prevent catastrophic water damage, and bypassing it is a guaranteed path to ruining your home.
And finally, a puddle doesn't always mean a clog. A restricted air filter or low refrigerant alters the thermodynamics of the system, dropping the coil below, freezing until it encases itself in ice, eventually melting and overwhelming a perfectly clear drain pipe.
The symptom is rarely the entire story.
So the application for you, the listener, is straightforward. The next time your AC suddenly dies on a sweltering afternoon, take a deep breath. Do not immediately panic and assume the compressor has exploded.
Right.
Look at the drain pan, check your air filter, and most importantly, respect what that small, frustrating float switch is trying to tell you. It is actively saving your house.
It really is the final line of defense. And, considering the sheer volume of water we were talking about, I want to leave you with a final thought to ponder that really builds on Dave's insights.
Oh, I like where this is going.
Think about it. Modern air conditioning units are pulling gallons of liquid out of our indoor air every single day to keep us comfortable. They're fundamentally altering the atmospheric conditions and the moisture levels inside our living spaces.
Right.
So how much of your home's long-term structural integrity, the dry ceilings, the pristine hardwood floors, the foundation of your walls, is secretly relying entirely on nothing more than one tiny, fragile, 3/4-inch plastic drain pipe, sloping at precisely the right angle in the dark?
Wow.
Something to think about the next time you hear that AC kick on.